Hi, it's possible to learn Kafka and event streaming with fun. Can I use a Let's Stripe to teach Kafka nicely and funly? Welcome to Build Your Own LED Race game with Kafka, where we will try to show you that yes, it's possible to learn Kafka with fun. My name is Igor De Souza. I'm currently a software engineer in a data engineer team. I have a good experience in development, especially in the big data scenarios and big data ecosystem. I'm being active in a maker community for a long time. And at IGFA Souza, you can find me in all social networks and email and my blog as well. So everything starts with this picture. A similar picture, it's shown everywhere, and people try to explain streaming or event streaming. So the events came and go for a data structure that is an array or a pipe or a band or whatever you want to call, that you can append the elements and you have a sequence, and then you can read from beginning to end. And of course, you can read an index and you can put this in a data warehouse. You can do some kind of updates. You can search, Elasticsearch, Solid, or things like that. You can use for ETL, and then you can put the result and create a cache. And of course, you can process even in memory or even on fly. And then the output can be another streaming and so on. So people use this picture to say streaming is a process of data in motion. Streaming is the data that is continually generated by different sources. Streaming is the continuous high-speed transfer of a large amount of data from a source system to a target. But if you look just the data stream itself, the green square in the center, so you have the sequence of the records. Of course, you have the concept of producer and consumer, the blue and the orange box. Blue can be more than one, so you produce data, you append them in the data structure. You have more than one consumer that can read and parallelize it. But if you have a look just the data, just the middle part, and you have a maker vision like myself, you're going to see something like that, a Let's Stripe. So can I use a Let's Stripe for teaching Kafka or data streaming concepts with fun? What I can do with that? So first thing that we are going to need is a Raspberry Pi. So Raspberry Pi started in 2012, and when they started, they advertised that was the smaller computer around the world. So since 2012 until nowadays, there is a lot of versions. They grow up a lot. There is the Raspberry Pi Zero that costs $5, and then there is a Raspberry Pi 4 with 8 gigs of RAM. That's around $70 or $75 ish. So, and then you have a lot of difference in the middle, more memory, less memory, more powerful, and things like that. The Raspberry Pi has the concept of the GPIO. So the GPIO is general port input output, that you can connect things. And of course, you can put sensors, lights, LEDs, and things like that. And you can use this in the code for turn on, turn off machines and things like that. The Raspberry Pi, as I said, is a full computer, needs an operational system. And the last version, the Raspberry Pi Foundation disponibilized the Raspberry Pi OS, usually to be called the Raspberry. They changed the name 1 year ago or something. And then, of course, there is already a 64-bit version. It's already came with Java 11 and things like that. They continue supporting the 32 versions. And then there is other Linux flavors, Ubuntu, Oracle Linux, and so on. There is the Android versions as well. There is the Android of Things, a Google project that for programming in Kotlin and things like that. And then the concept of hat. So the hat is a hardware that connects on the GPIO in the sense that you don't need solder anything, and then fits there and you can use it. It's just plug and play. So one of the hats that are on the market is that one. So Blink is from the Blink LEDs. It's from Primoroni, a provider. And then you have like some LEDs that you can turn on, turn off, and you can put this in Raspberry Pi. So you can end up with something like that. So here I have 5 Raspberry Pi, and each one has the Blink head. And I can use these LEDs for try to teach event streaming or Kafka. So each one can be a node, each one can be a topic, or maybe a partition. Of course, there is similar projects outside, people using this for teaching Docker, Apache Spark, or Apache Akka, and several other ideas. So a picture here that shows like you have a node, a master, or can be the leader, can teach concepts of replications, any other concepts. I can do some simulations, and then I have the Raspberry Pis turn off the lights. The lights can be a new node, can be an element, can be a register, a record, and things like that. And can I play with simulations? So like the website. So you can find it if you Google Kafka visualization software, you're going to find it this way. So I can try to do things like that. So showing the process of consuming the data, number of nodes, replications, and things like that. Another concept that I can try to play is the replication or the load balance. So here I have 4 nodes. Let's say that I have 4 different nodes, green, red, yellow, and blue. So if, for example, first one fails or get out, so everything that is on that node is going to be rebalanced for the others. And then if it is back, then rebalance again. One thing that we can try to do is when the node fails, I can hold a little bit of time and I don't do the rebalance. Can be like 5, maybe 10 minutes. And then if in that time I come back with the node again, I can just read it. I save the data, for example, in an object store in a cloud provider. And then when the node, or it can be in Kubernetes as well. And then when the node come back, I check if that value exists, and then I use it, and then I don't have the rebalance. So I can do these simulations using the pies and the heads, and on and off the lights, and I can explain a lot of concepts. Other kind of heads that we have in the market is on the left side, we have the sensor heads, and on the right side is the rainbow head. So sensor head, there is a lot of sensors, but he has a 8-to-8 LED matrix. And then I can use this for teach as well. So I turn on the LEDs. It's the same idea. And on the right side, I have the rainbow head. So the picture here is 8x8, but there is version with 16x16 and 32x32 as well. And I can create things like that, for example. So here is a tic-tac-toe game. Anyway, just showing they have 2 players, and then I have the tic-tac-toe on the LEDs as well. So I can use the Kafka for create the multiplayers. So the player 1 and the player 2 are playing, and all the informations go to a Kafka topic, and then I can read from the topic for show. The other thing that I can do is the reply or play again. So all the data that the producer generates go for a Kafka topic. Here can be player 1 and player 2, just using WebSocket for control who is playing in a web application. Can be Micronaut, Spring, or Quarkus, or whatever. And then I can have that topic, and then I use that thing for consume and build the dashboard, or build the game itself on the LEDs. And I can have this for a specific time. So then when I finish the game, I can just run the consumer again and replay the game, and I can see what's happened. So other things that I can do with the sensor head is, as I said, there is a lot of sensors. So pressure, humidity, temperature. On the right side, I have the GFX head. It's just a LCD. So then I can press, I have the 3 buttons on the bottom, 1 and 2 and 3. I have the buttons here as well. It's just touch. And then what I did is I press 1, I see humidity, here I see temperature, and here I see pressure, or something like that. And of course, I can do other stuff as well. Another one is the Anki car. So Anki car overdrive is kind of a game. It's a Bluetooth game that you control a car, and you need a race. And then because it's Bluetooth, you can get the data and you can analyze the data. So here is, I create small code that gets the data of the car in real time. So I have position of car, velocity of the car, position the track and things like that. And I can do some analysis. I can put the car for understand the track, create the best lap on the circuits, understand things like that. And then the other thing that I can use is the LED stripe itself. So LED stripe is exactly as the picture show. So a stripe that has a lot of LEDs, and then I can turn on, turn off, and can I use this. So more or less 3 years ago, I did the LED race. So the LED race is a game. So this video explains self-explanatory about the game, but the idea is kind of an autorunner of LEDs. So you have buttons, and every time that you press the button, the LEDs go further once. So then you can have 2 or 3 players or 4 players, different colors, and then you press the button as fast as you can, and the car goes forward. So the idea is that I have on the top I have the LEDs. So every time that I press the button, I go further. Can be 1, can be 2 or 3, depends of the LEDs that you're using. And then I can control number of laps, the player that do 2 laps first wins, and then for example, in my example was red and green, and then after 2 laps, the first one, all the LEDs are green or all the LEDs are red, indicated who wins. So where I can add Kafka on that. So I can add Kafka there for maybe create a visualization if I want to show a fancy dashboard, velocity, number of clicks per second, and things like that. More, because the Raspberry Pi, the last version has 8 gigs, I can even run Kafka on the Raspberry Pi. So the idea here is I have a LED stripe. My LED stripe has 60 LEDs per meter, and I have 5 meters. So I have 300 LEDs. And then the idea is when the game starts, I have the player playing the button as fast as he can. But if you put this in a keyboard or if in a button, you have some kind of limitations. You're not able to do like 3 clicks per second. So you end up with average 1 or 2 clicks per second, and takes around 1 or 2 minutes for giving, I don't know, 2 or 3 laps, depends of how you set up. So the idea here is that I have 2 registers, 2 records per second in a windows of 1.5 minutes or 2 minutes, and then I don't have anything. So throughput here is quite small, and I can run on Raspberry Pi. And then, of course, everything can be Raspberry Pi. And it can be a cluster, it can be several ones. See, on the top here, I have the producer 1 and 2 and 3. Could be the players, player 1, player 2. I can build the game with up to 4 players. I can put more, but then it becomes difficult to see the colors, and the colors overlap and things like that. Of course, I use the Kafka to control the stripe, but I can have the Kafka, I use the Raspberry Pi to control the stripe, but I can use the Raspberry Pi to control the Kafka as well. As I said, the Kafka can be on the Raspberry Pi. I can have a cluster of 1 or 2 or 3. Can have one specific for each player. So I have Raspberry Pi 1, player 1, Raspberry Pi 2, player 2. Can have Zookeeper or without Zookeeper in the version 2.8 or plus. And then I can have my consumer that get the data, generate fancy boards or dashboards and things like that. Real-time data, velocity, and things like that. Best lap. And then we talk about the concept of edge, so it's Kafka on the edge. And when I talk about Kafka on the edge, I mean Kafka clients and Kafka broker running on the Raspberry Pi itself. Of course, I can do a replication this for my computer, for a cloud, for whatever. But the main idea that is running on Kafka, as I said, it's a short period of time, less than 2 minutes, that I have a lot of requests or submissions or records, and then I don't have anything. And I can create more nodes, 1 for each player or 2 for each player and things like that. And then, of course, I can replay it again. So the same idea that I did the tic-tac-toe, that I have the history, whatever happens on that game, I can replay and he watch my Led races as well. So I did the race, I saw the race, all the data is already in my stream, so I can just read it again and replay it. So the concept here is the yellow on top is the LED stripe. So I get the data from the LED stripe, I put on Kafka, and then on the other side, I consume that thing and I can do it again. So we end up with the same result. So this is, I'm not playing anymore, I'm just doing the replay. Whatever happens in the game is happening. Another thing that I can do it is when I click the button, I can do a lot of things. So click the button here, move the LEDs forward, click the button here, submit that I did the click for a Kafka top. Player 1, player 2, and things like that. So I have the click itself, the player, I can have time, then I can calculate velocity, many clicks per second, and things like that. And I can do dashboard. So here I can have the speeds, clicks per second. I can have the velocity of the LED, player 1, player 2. I can have best lap, I can track the lap, best lap, can have best lap of the game, best lap overall, and things like that. And of course, the same way that I have dashboards for the game, I can end up with a dashboard for the Kafka itself. So can control, here is a Grafana example, but can be anything. So I can have the information about my Raspberry Pi, memory, consumption, number of messages, the time, and everything regarding using JVM metrics here to get information about Raspberry Pi. So then I can see if it's able to run in Raspberry Pi or not. Should I increase the number of nodes or not? If I put just one for 2 players enough, or I need 2, 1 for player 1 or 1 for player 2, and things like that. And I can analyze and understand what's happening. And then on the top of that, I can add more ideas. So I can create other games based on the LEDs, based on the heads that it has LEDs, or based on the LED stripe. I can add more ideas and create more games. So this is kind of idea that I can follow up with more ideas, more games, and things like that. So one thing that it's funny to realize here is number of message, the size of the message, the number of the message, and then megabytes per second. So here I create a table with a code that I was trying, like increase the number of the size of the message against number of messages per second. So in the first line, I send 5 messages. Sorry, I have messages of size 5 KB, and then I end up with 1,316 messages. And after a specific period of time, I managed to calculate that I was with 6.42 megabytes per second. And then, of course, I increased to 10, number of messages decreased, and things like that. And the last one, you can see 750 messages. I have only messages, and then I have 8. But if you look on the middle, like the 101, so I have 98 messages and I have 9 megas. So there is no correlation here, relation between the number of messages and the messages per second, and on the end, like how many megabytes per second I can end up. So then we can create a game on top of that. And that game will teach you how to calculate or how to think in a fast way. Should I increase the number of messages, or should I send less messages but with a bigger size? So imagine the game. 2 players, web application that has 2 players. The application can show you the size, or the application can show you the number of messages. The application gives you 30 seconds for the site, and then in the 30 seconds, you need to read and try to fill a form regarding what is the size of the message that you want to send. So, for example, imagine I receive a random number. So start with 5. So I have 30 seconds for the size of the message for send 5 megabytes per second. And then player 1 and player 2 decide the value. I decide 1, decide 3, or whatever. And then once the 30 seconds finish, the game starts. So what the game are going to do is they are going to play the red race, but instead of the person play the button, the game is going to play itself. And the LED is going to move. It means another message. And then you're going to see the velocity of the cars, and who chooses the best number is going to finish. So we end up with something like that. So here is red and green playing, and the car is moving according to the number of the size of the message. So the person who chooses the best message for that value, here is a demo that I was playing, but the person who chooses the best value is going to show. So if I come back here, so the idea is a game that 2 persons are playing, and they need to choose the best size of a message for achieve a specific value that came random in a megabytes per second. And then the same way that I do for a message size, I can create a second game that is going to be messages per second. So the game itself is going to ask you how many messages per second do you want for a specific value. And it can be the opposite. It can be a third game that is going to be the megabytes per second. So the game is going to say number of messages, and then you're going to need to put the megabytes per second. So I end up with 3 games that you choose. You receive a handle value, and then you need to choose. And based on the value that you choose, the gameplay itself. And when I say the gameplay itself, what's happening is I created a message with that size, and I submitted up to that specific amount of that I want. And then every message that I submit, every message that is consumed, it's an position that the car goes. As I said, I have a LED stripe with 60 LEDs in 1 meter. So if I use the 5 meters, I have 300 LEDs. So I end up doing some calculations regarding 300 divided by the size of messages and things like that, just for make sure that when you send the entire messages, it's 1 lap. So that game ends up when finish 1 lap. So a little bit complicated to understand the concept of the game, but a simple GUI and a simple explanation of how the game works, and I can teach you a lot. Can teach a lot of information about event stream, Kafka, and how to calculate numbers of messages against message size against megabytes per second. And then the game, it's self-explanatory. So here in this video, I'm doing the demo that I use Maker. So Maker is another board that you can simulate the clicks in a contactless. So here I have a doodle, the play. So every time that I touch the thing, simulates a click of the keyboard. And of course, when you talk about keyboard, we have some limitations. As I said, if you try to click as fast as I can, even if you manage to do it maybe more than 3 clicks per second, it's not going to take in account because the keyboard has the limitation of 3. So you end up with average 1 and 2 records per second, but if you go really fast, perhaps you can achieve 3. So Kafka, event stream, LED race, everything done in a really nice and a funny way. The idea that I explain here, as I said, I create a game on the top of the game or on top of the game. And of course, you can come with more ideas and can create more games. It's kind of a without end idea. I saw people doing similar stuff regarding Apache Spark, Akka with the LEDs, or the cluster to showing who is the leader, load balance, and things like that, even with Kubernetes. And the other thing is all the code that all the demos that I show here and all the codes are going to be in my blog and my GitHub. So if it's not there, we'll be there. So be patient. One day we'll be there. And check out my blog as well, because small projects became small blogs. So you can find me on IG Souza, as I said, and all social networks with that thing, Twitter, LinkedIn. You can find my GitHub as well, the same, and at gmail.com is my email, and my website and my blog. You're going to find all the information there. So I want to say thank you for the opportunity. Thank you for the presentation, and I'm going to be on the chat for answer all the questions. So thank you. Bye.